of pods and resources starvation are ways that your pods may encounter every day. Tactics to avoid optimization fatigue, the best ways to drive good resources budgeting and the right team culture, and how our tips and tricks for using HPA and BPA. So I'll stop there and I'll kick it over to our presenter, who is Mohammed Ahmed, who is our founder and CEO. Mohammed, perhaps you could give us a little bit of a bio about yourself before we get into the talk, and you can take it from here.
Sounds good. Thank you, Jahid. Just wanted to make sure, can everyone hear me? Can you hear me okay, Jahid?
Yeah, we can hear you just fine.
Cool. And I remember that I had some camera issues earlier today. Can you see me?
We cannot see you yet, actually.
Okay, just 1 second. Let me fix that.
Thanks for sticking with us through these last few little tech issues. Participants, much appreciated.
Now, any better? No, you cannot see me, huh?
We cannot see you, sorry.
There we go.
There you are, perfect.
Can you see me now?
Yep.
All right, cool. All right. Oh, let's get started then. I will just open up the my presentation or the slides for today, and then we're gonna get started immediately. All right, sounds good. So let me start by sharing my screen.
And also participants, before Mohammed gets going here, if you have any questions, feel free to use the chat. Feel free to use the Q&A feature. We'll be answering them shortly towards the end. We'll have a 15 to 20 minute section reserved for questions.
Sounds great. All right, cool. So let's get started then. Everyone can see me. Voice is okay. Can you see my screen as well? All right. I think
yep.
we're all good.
Yep, we're good.
All right, so let's get started. All right, so welcome everyone. Thank you very much for joining us today. It's a pleasure to have everyone, to just share our experiences, share our tools, and how we think of the capacity management inside Kubernetes. This is part 3. We previously had 2 webinars, which I'm going to recap really quickly in the next few slides. But before we get started, just quickly about me, I'm the co-founder and CEO of Magalix. I worked before at Microsoft and AWS. Had the opportunity to work with great engineers, great teams, work on interesting problems. And then I joined after that a company called Climate Corp, which actually took me at the other side of the table, working as a customer of the cloud infrastructure. And it revealed a lot to me and the challenges that many engineers and teams face while using the cloud. And from that, I learned a lot about the capacity management and about how to help companies and teams move fast. And then after that, I co-founded Magalix with the promise of making cloud infrastructure much easier to use and help teams to be efficient. Climate, we do, we're basically smart guardrails to help teams to do governance and operational excellence. So today we're going to focus on one aspect of the operational excellence, which is capacity management, and specifically how to do this inside Kubernetes in a proper way. So last 2 webinars, as I mentioned, we're talking about the general framework and how to select the right matrix. Today, we're going to focus on how to select or how to set the right limits and requests for your pods and containers inside Kubernetes. Even though they're just 2 variables that you play with inside your specs, but there's a lot actually that need to be done in the background to set those values properly. So today we're going to focus on that. And we still have another webinar that's going to talk about how can you characterize your workloads, how can you create the right node pools for your cluster, so that you have the end-to-end capacity management properly done inside your cloud native stack. All right, cool. So that's the agenda for today. As I said, I'm going to recap the last two parts. I'm going to also focus on what are the different scenarios that you need to focus on. I'm going to show you a demo really quickly on how to manage these inside Magalix, and how we are going to help you to do this very quickly. Share some tips and tricks away from Magalix as a tool. What are the right cultural elements? How you should think about it. And if we have time, I might talk a bit about the VPA and HPA. Many teams started using it. There's some quirks that you need to have in mind as you decide to use them, or as you're actually trying to optimize them at the moment. So in part one of this webinar series, we were talking about the whole framework, and it was a 5-step framework. And we were trying to basically just set the ground for all the the other parts that we are now progressing through. Why capacity management is important. What is capacity management in general? And we mentioned there's a balance between performance, resources, and the cost optimization. You need to balance all those three elements together, so that you have the best ROI in your infrastructure without crippling your team in their progress as they deploy more containers and pods. And we talked about the 5 steps, starting from connecting the right metrics together, to building the right dashboards, adjusting pod resources, which what we're going to focus on today, and then how can you select the right VMs for your Kubernetes cluster based on the previous steps, and finally optimize your build by selecting the right billing structure for you. And what are the common mistakes that you should avoid as you implement that framework? So if you haven't attended that part, strongly encourage you to go to our website and download it, or just see the recorded version of it. All right. The second part, we talked about the matrix. Now we started to zoom in and talk about the matrix, talk about the dashboards in a more elaborate way. How can you set the right KPIs and the right service level objective, and connect those to the KPIs, so that you have the right traceability within your system. At the end of the day, you want to optimize for your customers and for your users. You want to have the best possible experience for them. That's number one goal. But at the same time, you want to connect this to your resources, so that, or the use of CPU, memory, disk, network, etc., so that you have the best match between these two. I can still get the best possible KPIs, but I might be spending 4x or 5x than what I should be spending to get those KPIs, with the proper thresholds and numbers. So we started with that. And then how can you create, of course, the right resources and usage profiles? Is your pod or microservice CPU oriented, or kind of CPU intensive, or memory, or something else? And how from this point you can actually do the right affinity and allocate your microservices to the right nodes once you select the right pools, or create the right pools within your cluster. So that was part 2. Today, we're going to focus on step number 3, which is, okay, I have the dashboards, I see those connections. Now, how can I adjust my limits and requests for my pods? And as I mentioned in part 1, you cannot really optimize your VMs without understanding how much resources each one of your pods and containers would need. Because if you are not setting the limits and requests properly, you're not going to know how much you're actually using versus how much is available, and how much of a waste that you have inside your cluster. So today we're going to just focus on that. Okay, cool. So just back to the fundamentals. For those who do not have much of an experience with Kubernetes, quickly about the limits and requests. Requests basically and limits are applied to CPU and memory. There are other resources types inside Kubernetes, like ephemeral storage and some custom resources that get defined. But today we're just going to focus on these two. So request is basically the guaranteed minimum resources. When you set it up for memory or CPU, Kubernetes scheduler will make sure that this pod is scheduled to a node or allocated to a node that has enough resources or that minimum resources for your pod to run. So it basically guarantees the minimum resources for your pod. Limits is basically considered a protection for your system. It makes sure that your pod or container does not exceed the use of the specified CPU and memory. If it goes beyond that, in case of CPU, it gets throttled. In case of memory, it gets killed. OM kill is one of the most famous crash reasons inside Kubernetes if the limit is not set properly. But the limit is considered a protection or a guarantee that your system can still function relatively without a major disruption if one of your pods is behaving abnormally or not basically using the resources or not running within the resources that you would allocate to them. That's the whole idea behind the request and the limits for CPU and memory. CPU, as is called, is a compressible resource. So if you try to use more of it, basically your pod is going to just suffer from performance issues. But in case of memory, because it's not a compressible resource, once you exceed what is allocated to you, in case if you have a hard limit, it's basically your container most likely is going to crash, or the OS is going to kill it. And then it restarts again until hopefully it doesn't go to that, doesn't exceed that threshold and just runs normally. If it exceeds that threshold, it doesn't matter. It's going to go just crash over and over again. So that's just to set the ground here, make sure that we all have a common understanding of, what is a request, what is a limit. And there's a lot of literature, lots of articles, either at our blog or Kubernetes.io website. You're going to find a lot describing each one of these two. All right, cool. So as I mentioned, we're just going to focus on these two resource types. Others already described at the Kubernetes official documentation. We're not going to discuss them here. They have their own ways of management that can be discussed later on. All right, so let's now just focus on understanding all the possibilities. What are the different scenarios that you can go through, or possibly your pod will go through when it comes to allocating CPU and memory? And there are four major categories. The first two is basically, this is the most common one. A developer, a DevOps, to be safe, they want to allocate enough requests and limits in a way that they do not want to think about it for a really long time. So most of the time, they over allocate requests or limit. And that's understandable because you do not want to really, just tweak that value every day or every few days. You want to just set it once and make sure that you have it. You have enough values that would take you, let's say, throughout the month or the quarter, and be able to just focus on the other stuff. And that causes a lot of waste because you basically just over allocate. You want to forget about it. The second scenario is missing CPU memory requests or limits. And this is also another way of possibly creating a waste, but you're just throwing the problem on the VM. You basically do not allocate requests or limit, and you say, you know what, let me just run it, and I'll make sure that the VM would have enough resources. And of course, that can cause either pod or a system instability in general. The pod may not have or get enough resources on a VM. It gets allocated to a VM with no guarantee of resources, and then all of a sudden it can crash because all the other pods already took the memory, or it has a performance issue because all the other pods are already consuming all the CPU available on that VM. So that's also another scenario that you may go through if you are not allocating the request and limits. I'm going to dig deeper into each one of these, but I just wanted to give you an overview. CPU starvation, which is basically you get a performance hit due to high throttling. Your pod gets throttled because it's using a lot of CPU in a very short period of time, and exceeding what is being allocated to it and then limited to for that, or the value of the limit for that pod. And the final one is memory or CPU high utilization. Those are basically scenarios. This is a scenario where you have a CPU and memory that is allocated for the container, but your container or pod is getting really close to the limit. It's not, in case of the CPU, it's not really being throttled, but it's very close to the limit or the request value. And the same thing for the memory. You have a very high utilization. Pretty much, if you would compare this to the conventional VM word, it's basically pretty much like having a VM that's running 80% all the time. It's fine. You can still go with that, but it's really dangerous. That VM might crash anytime due to over allocation of memory, or might simply just become unresponsive. And of course, that would impact the stability of your system in general. At Magalix here, actually, we support all those scenarios. We tell you when your pods or containers are missing the limits or requests, when they're basically possibly having a lot of waste, and when you should fix them within your system. So this is something that we cover them in more detail, and in the demo, I'm gonna show you maybe a couple of these. All right, cool. So let's dig deeper in each one of these. CPU or memory waste. As I mentioned, it means that you're allocating too much requests and limits, and this is one of the most common scenarios that you would see inside Kubernetes. Why should you care about that? Why would you basically, care about reducing the CPU and limits rather than just over allocating? As I mentioned, it's better scheduling in general. You may give your pod too much of, let's say, memory request, and then when Kubernetes tries to allocate that pod, it's not actually scheduled properly. It may just be in pending state for a really long time, or maybe forever, because there are no VM that can actually get that has enough resources for that pod, even though that pod in reality does not need all those resources, as in case of memory or CPU. And of course, eventually, it's going to help you to save money. One of the problems that we also come across with some of our users or customers, that, okay, I allocate the CPU and memory, and I do not see a space for me to really reduce the number of VMs or reduce their sizes. But when they zoom in and take a closer look at their pods or containers, you realize, yeah, maybe pods or containers are running just with a few resources, but because of the allocated CPU allocated limits and requests are quite high, they basically they see it from outside as they're just using all of them. Of course, the indicators for that is compare the usage to the allocated values. Make sure that for the CPU, check the 90th percentile of your CPU usage throughout the last 7 days or 24 hours. Make sure that you use for the memory either the 10-second average or for the request, and of course use the max to set the limit. And actually, this is one of the things that we measure inside inside our tool at Magalix here. Once you connect your cluster, you're going to see all this data flowing in with the recommendations. This is an example here of a pod that is actually over allocating memory for both the limits and requests. And you want to make sure that we wanted to make sure here that the user or that particular pod is having the right allocation. And we actually apply the 90th percentile for CPU and the 10-second average, and use the max for the limits to allocate the limits for the CPU and memory. So this is just to give you a hint of how this can possibly be solved quickly. The second scenario, which is missing CPU, CPU or memory requests or limits, which is basically either one of them or both of them are missing. In case of missing requests, as I mentioned at the beginning, there's no guarantee of resources, and you may have a scheduling issue as a result of that. Or your pod can crash as a result of that, or just even not being scheduled at all. It just runs in pending state. in case of missing limits, and I know that missing limits is a debatable issue with many teams. Some teams or some engineers will say, you know what, I don't want to allocate the limits. It just caused my pods to be throttled, and it's not a big deal for me. And some other teams, you know what, no, I want to have a good one. I want to apply the best practices for me and for my team, and I want to set the limits to know exactly what is going on. Now, the problem was I'm actually pro allocating the limits, so setting the limit for your pods. The problem with not setting the limits is pretty much like you may have actually a chaos monkey. Implicitly, you might have a chaos monkey as a result of that. But let's actually go through that scenario together. I have a pod that doesn't have a CPU limit, and then or memory limit, and then that pod is basically just take all the requested, goes up in its usage with CPU and memory, and then all of a sudden it monopolizes the whole VM. Now, in case of CPU, what is going to happen here is the container is the VM becomes unresponsive. The VM basically all the other containers are gonna suffer because of the noisy neighbor problem. It's not limited anyways. The pod is not being confined within any limits to use the CPU, and then your VM becomes, as I said, not usable. Possibly the other containers might crash and get reloaded somewhere else. In the case of memory, if you do not have the limit and then your container or pod goes up in usage, basically is going to go all the way to the maximum of the VM, and then it crashes, and then it goes to another VM as a result of that. The other pods inside the VM also are going to suffer the same. They're going to go up in memory, and then they're going to eventually crash, and then they're going to get restarted and possibly get restarted at another VM, and then if it goes throughout the same the same pattern, is going to also crash there, or possibly it crashes to other pods and containers in the other VM and so on. So it's going to become very hard for you to really diagnose. So that's basically one possible side effect of not setting the limits. Well, some might argue and say, well, I don't have that situation. My pods are well behaving, not a big deal. This is completely fine. But again, you're just having that risk of having stuff being crashed or unexpected behavior to take place, possibly at night, and you get paged as a result of that, and then it takes you maybe 1 or 2 hours to basically to diagnose and understand the root cause. So as I said, it's easier to plan. That's why you should carry. It's easier to plan to do it and help you to do this, basically implement that best practice. And it's going to help you to plan the cost and capacity in a much easier way. It's going to definitely improve the overall stability of your system. It's easier to fix at the beginning, and if you ignore it, it's really hard to diagnose and identify the root cause if this is the case with you. You can write a policy to basically just, if you're using OPA or if you're using Magalix, because also we support this, you can simply write a policy to tell you or get the list of all the pods that do not have any requests or limits. And this is also something that we capture ourselves. And the snapshot that we have here is one of the recommendations that we provide to specifically cover that scenario. All right, CPU starvation. CPU starvation is basically is an interesting scenario, and also it's a debatable kind of situation for many engineers using Kubernetes. You might have your CPU, your pod acting properly. It's using the CPU within its limits. It's not really exceeding them, but it's using the CPU at a high intensity that is not really matching the scheduling algorithm of Linux. And there are lots of articles talking about that. And we have actually a couple of articles on our blog talking about the CPU starvation in general. So when you allocate, just in a nutshell, when you allocate, for example, 1 core to your container, and then your container decides to use more than 200 millicores in the first 200 milliseconds of this second, basically the kernel, the Linux kernel, is going to throttle it because it's assuming a uniform use of the resources inside that 1 second. If your pod is bursty in nature and how to use a CPU, is going to get throttled, and eventually it's going to impact its performance. So this usually happens when you set the limits too low, or of course there are some noisy neighbors that you have on the VM, and that's something that you should actually really care about and focus on, getting the right visibility to, so that you fix, adjust your limits for the CPU. This will help you to avoid unpredictable performance degradation, like the example that I just mentioned, and of course is also going to improve your system reliability, because you're not going to have containers impacting others. The main indicators is how many times a pod or a container got throttled in a second. That's the metric that you should care about. And this is also another thing that we monitor inside Magalix. This is something that we really care a lot about, and that's why we run it as own category to help you avoid performance penalties. And this is the snapshot that we have here. Actually shows that this is an example of the reports that we give you for each container. All right, memory and or CPU high utilization. And as I mentioned, this is simply, you're just very close to the limit in case of the stateless, pods like deployments and so on. And of course, the utilization is very close to the request in case of stateful sets. Now, Kubernetes does not really differentiate between stateless and stateful. This is something that we, based on our experience, we think that this is how you should care about the utilization for your pods. If it's stateful, you should really look at the request. If it's stateless, look at the limit, and it's just basically due to the nature of each one of those pods. Why should you care? Again, you just basically avoid unpredictable performance degradation as a result of that, because again, you're very close to using the all what is being allocated for that pod. You're most likely going to be throttled at a certain point. In case of memory, most likely you're gonna the pod is going to be OM killed at that point. And the snapshot that we have here is actually gives you a very good example of a pod that is having a very high usage, but is not yet throttled. It's very close. It's just it could be actually throttled at a certain point if you do not really adjust the request and the limits for that. And this is actually what for that particular pod, we're giving it more limits and more requests to make sure that it's not going to hit that wall in case of CPU. We do the same thing, of course, for memory. The indicators, the maximum of your memory is basically just reaching 80% or more. This is an arbitrary number. You can set that number to a lower or higher value. If you want to take more risk, let's say it's a dev environment, you don't really care that much about the stability of it, that most of the time you can make that number 90%. In case of production, you might want to be more sensitive and maybe make it 70, 75% to give yourself some sort of a margin to adjust those whenever needed. All right, cool. So those are the scenarios. Maybe I'll just quickly jump to a demo, maybe show you how some of those scenarios we are capturing inside Magalix, and then we're going to jump into the best practices and tips and tricks about managing your CPU requests and limits, or on memory as well. So let me exit the presentation mode and just jump quickly to our dashboard. Okay, so this is our console, and that particular account has 6 connected clusters, and just basically shows you the status of each one in terms of compliance and performance and so on. So let me zoom into one of those clusters and specifically zoom into the optimizations part. So as I mentioned, let me zoom in here a bit. As I mentioned, we actually capture a lot of those scenarios, or all the scenarios that I mentioned that you really want to care about. Containers wasting memory resources, missing CPU and limits, and so on. And actually, we cover also some other aspects, which is basically cost saving and improving the performance, or improving the overall capacity to improve the performance of your cluster, which is something that we're going to cover in the next webinar. We actually here give you recommendations on the best number of nodes and how you should organize them, and the type of nodes that you should have for your cluster. But let me zoom out again and just maybe click on one of these, zoom in differently. So for example, for that cluster, we have an InfluxDB that is running. And that basically, that container, is basically over allocating the memory, or the developer or the DevOps engineer decided to over allocate the memory, or it was over allocated at that particular point, but now it's time to reduce that. So here there is 1.4 gigabytes of memory that can be saved for that particular container. So this is something that just to give you an example of the memory allocation. As I mentioned, it could be the value that was allocated maybe 2-3 weeks ago was okay, but right now, because there's less workload, it's not. And actually, we're showing here the history of the recommendation. You can see that starting October 5th, actually the pod is considered consuming or having too much of memory allocated to it. You can fix that here with the automation by just clicking apply. Our agent basically is going to fix those limits and requests for you inside your cluster. So you do not have to do anything beyond what's actually provided here. I can actually jump to another type of optimization, which is the throttling specifically, and then I'm going to show you all something really cool here that we are about to release, but we are just basically placing it behind the flag, but I'm going to show you that in a bit. So let's go to container starving in CPU. We do not have that many here, but I can go to another database, an InfluxDB database, and that database actually is actually having the limit that is too low. The request and the limit are equal, which is dangerous, and basically that means that the database can be really throttled. So in that case, we're recommending you to allocate 24 cores. And by the way, the 24 cores should be available within your cluster. I can actually maybe pick another one. Let's see if this guy is being throttled. Yeah, here we go. So we have here actually another container that is not necessarily exceeding the limits or the request, was being throttled. And this means that basically this performance is going to be degraded. Even though the request does not need to really change, that much, only 5 millicores, but the allocated limits are really too low, and that's causing that kind of throttling to take place. So if you just change that here, you're going to basically have a happy pod that is not going to be throttled. Now, quick thing here that worth showing you guys before jumping back to the deck is the ability to basically just prioritize what you need to implement. In that particular cluster that we have here, we have around 79 recommendations are being generated to optimize that cluster. But let's see here how much actually those are going to save me. Does it really worth my time or not? So I can show you something really quick here. Actually here, maybe I just use the pie chart. I have I have a total of 265 gigabytes on that cluster. My top 25 entities can save me around 21% of my wasted memory. This is around 56 gigabytes. So I do not really have to apply, all the reported waste. Some of them are really small that you do not really need to look at immediately. You should run efficient as much as you can, but some of them are low-hanging fruits that you can really optimize right now and do big savings. And this chart here, or that feature here, would show you actually the top, as I mentioned, the top 25 entities, or even the top 10 entities that you can apply the optimization for. In case of wasted memory, for example, here you can also see the other ones in case of CPU, in case of also CPU. Now, one last feature, really cool feature that we have here is basically the automation of those requests. You can actually select some of these. So for example, I can say, look, I would like to see only the ones that are missing memory limits or CPU limits and requests, like the ones that we're having here. I can select them and I can say apply them. And applying them basically is going to send back those updated values to your cluster, and Magalix agent is going to apply them for you. So even fixing those is something that can be done very quickly here. We do a lot in the background to make it really simple. The execution part is considering a lot of things. We do not consider and we do not move to the next automation or next recommendation before the previous one is actually executed properly, or at least if it failed, we revert it back and make sure that you have a running container with the old values. And we send you a notification telling you, hey, you need to take a look at this. This is something that worth looking at. So I'll hit cancel here, and then this is just an example of some of the failed and and successful automations and who actually executed those recommendations at a certain point. So this is just a cool automation feature that I thought of also sharing with you here. All right, so this was it for the demo. I wanted just to focus on the different scenarios that we can help you to manage the CPU limits and requests for your inside your Kubernetes clusters. All right, so let me go back to the deck, and then to just basically go through some tips and tricks and the best ways to manage your limits and requests, and then we're going to be up for Q&A. All right, cool. So very important thing that you should have in mind, whether you're a developer or a DevOps or anyone who's touching the cluster yourself. Avoid optimization fatigue. Some teams, they basically say, okay, I have 500 containers of pods. I can really optimize all of these. No, don't do this right now, immediately or as a first step. First of all, think of what you really want to fix. What is the biggest problem that you have? Is it the bill that you got from the provider and you need to basically do some cost saving? Are you having reliability issues and you want to make sure that your cluster is stable enough, or are you having performance issues that you want to fix? Focus on what really matters for you at the beginning. That's number one. Number two, tackle the most impactful waste or the most impactful containers. Do not really try to boil the ocean and try to fix everything at once. Take a look at the ones that are causing most of the waste. For example, if you want to save some money, we notice in majority of the cases, majority of the cost saving, it comes from the top 10 or 25, and that's why actually we are releasing the feature to show you how those are actually going to save you probably a big chunk inside your cluster. And the long tail, you can definitely handle them later on, but you want to just basically feel or see the results of your optimizations immediately by just tackling those top ones. You want to balance at the end of the day the cluster efficiency with your team's efficiency. You don't want to bug your team, or you spend all the time trying to optimize. You do not want to optimize every day, and you do not want also to optimize every 3 months or 4 months. This is too far in the future, and it's not the right frequency. We recommend to take a look at your resources maybe once or twice every week, once a week, or maybe once every other week, because basically this is going to reflect a meaningful change in your workloads, a meaningful change in in how your pods and containers use resources. It depends on how fast you deploy and upgrade your your microservices. Now, so this is basically what you want to do. And also one last piece that also worth mentioning, and this is something that we debated a lot internally here. What is the minimum value that you need to allocate for your CPU and memory? If you're for a particular pod, let's assume that your pod is using maybe 10 millicores or 20 millicores, and we've seen a lot of cases like that. How much would you allocate to that pod? Would you allocate only the 20 core that it needs, or would you maybe give it a margin and allocate 30 or 40? It's not going to make a big difference, in the in the from a big picture perspective, but it may make a difference for you in terms of how frequently you're going to basically revisit the allocation of resources and limits. Now, I mentioned at the beginning that this could be the biggest source of waste, and a lot of developers might use that to basically just give a big margin and generate a lot of waste. Now, I want to just mention here, I'm not talking about all your containers. Do not do this for containers that say that are using 1 gigabyte of memory or multiple cores. Do it for the ones that are really small in usage. You don't want to, you know, optimize every week or so on just a half a core or a few millicores. You want to really optimize for big stuff. So also set a minimum request for the CPU and memory to do that, and that's a setting actually that we have for our advisors that you can set for your own clusters and so on. As I mentioned, just tackle the top one. This is an example chart that I just showed you that will tell you the top entities and how much they would be saving. Now, not all containers are treated equally. Do not really, treat your stateful set like deployments or other stateless containers. Stateful sets or databases in general are very expensive. The impact of their crashing or instability is high. So you want to be really sensitive with them. You want to make sure that you're over allocating. This is something in some cases. And this is something that actually we consider inside Magalix. When we give you a recommendation for stateful sets, we consider the type of the entity, and we want to make sure that this entity specifically is the most stable. Don't overlook assigning limits. As I said, it's easy to ignore, but it's really hard to troubleshoot if you get into that situation. Educate your team about it. You do not want to spend PRs, your time in PRs reviews, because at the end of the day, it's really hard for one person to manage, or maybe a few engineers to manage the limits and requests of everything. You wanted everyone to help you out. And you want to basically just be transparent about that. Either build the dashboards, or you can just connect your cluster, as I mentioned, and try it out with us. We allow you to manage hundreds or thousands of containers in an easy way. You can filter them out and tackle the most impactful ones. All right. I don't think that we have time for VPA and HPA, or to just run and handle them in depth. But really quickly, I know that a lot of people are either using VPA right now or thinking about using it, and HPA. They're really powerful pieces or addition to Kubernetes, and we use them internally inside Magalix. But you wanna be careful about some aspects of using them. VPA specifically is really nice and cool, and allows you to vertically scale your pod. But the problem is, because it's reactive, it may require your pod to be restarted. And sometimes the restart of those pods might be expensive, might be really hard to manage if it's happening in the middle of the night. Versus you proactively scale that pod at the right time, and you're just ready for any changes in your workloads. So that's just one tip to consider here about the VPA. HPA also really great tool for horizontal scalability, and we're using it. But you want to consider also that it takes 4 to 18 minutes for pods to scale. And it takes time for matrix to propagate throughout the system and for HPA to capture that and take care of it. If that's enough time or enough window for you, in the best case and worst case scenarios, then that's fine. But just have this in mind. And we have an article talking in depth about both of them. Just go to our blog and just go to this article, Kubernetes Autoscaling 101, or just search it in Google. You're gonna find it among the top 10 results to see how you can use VPA and HPA at different situations. Magalix scalability recommendations and execution does not contradict with the VPA and HPA at all. They work. They can work side by side. VPA and HPA are reactive. Magalix is proactive, and you have more control on when you apply the recommendations and how you can apply them, rather than having those reactive measures inside your cluster. You still need both. All right, just a quick recap here. We went through all the possibilities. We talked about all the 4 scenarios, memory and CPU waste, missing CPU and memory requests and limits, and how this impacts the stability of your system and your pods. The CPU starvation scenario, where you have a lot of throttling taking place, memory and CPU utilization. You're really close to the limits of your pod. Especially in CPU, there is a high utilization, but you're not yet throttled, but you're about to be throttled. So we handled that as well. And of course, we talked about the best ways to handle that. So that's it for today's webinar. Hopefully, you got something new out of it. We are going to continue our series and talk about what is next. Usually, you need to adjust your limits and requests before you move into changing the size and the types of the VMs that you use inside your cluster. You can change the order, but it's not the most efficient. And this is one of the most common mistakes. Some companies or some teams will go and just try to buy reserved instances of VMs or try to optimize the VM, and then they get hit by their pods being disrupted significantly. So you want to take it with the right order. And then once you do it and build the cadence, build the memory muscle around that framework, you're going to be able to do it really quickly. And some of them may not need to be reviewed every time you review your capacity. Requests and limits are the most frequent, and the least frequent is changing your VMs. All right, that's it. Thank you very much. The upcoming webinar, as I mentioned, is going to cover the last 2 steps in that framework. On how to select the nodes and create the pools or the grouping of your nodes in a proper way to basically get the best ROI out of your capacity inside Kubernetes. All right, just connect today to your cluster to Magalix. Just go to magalix.com or console.magalix.com. Just you're going to get a single command line, and you can get all the recommendations. We offer a 14 days trial. You can get all the recommendations and automate them even, considering all those scenarios that I mentioned today and even more. And we keep optimizing and enhancing it over time. Cool. That's it. Ready for any questions, if any.
Cool. We have one from Parva before they left. It is regarding HPA and VPA. So both of them come out of the box in Kubernetes and are basically the go-to way for handling auto scaling. Why should we consider other forms of auto scaling? Like why are HPA and VPA not necessarily good enough? And what can we do?
That's a good question. VPA and HPA could be enough for some teams, but as I mentioned, they're reactive. They're basically waiting for something to happen before you can scale your service. While it might be good if your scale, if you want to scale significantly in a very short period of time, but they are not going to give you, the peace of mind of really looking after everything. Usually, what I notice that teams are focusing on a specific microservices to use the VPA or HPA with, but they have hundreds, possibly hundreds of containers and pods inside their cluster. Are you really willing to do the configurations of the VPA and HPA for each one of them? or you want to basically be proactively and with a minimal effort ready for any kind of you know spikes in your workloads. Now, some of the workloads are really hard to predict, and you still want to have the reactive model, but that's not everywhere. And you do not want again to just limit yourself waiting for some reactive mechanism only to be implemented inside your cluster. Be proactive, make it easy. You usually have hundreds or sometimes thousands of pods. You do not want to configure VPA or HPA for all of them, and also you wanna make sure that um, your system can handle those in a proper way, and your team can handle those in a proper way without really getting into too much kind of configuration and changes inside your system.
Cool.
Cool.
And
Hopefully
one
that
more.
answers. Yeah.
Oh, sorry, well, sorry to cut you off there. One more. Um, you hear a lot about continuous improvement and a lot of stuff about how DevOps is culture first. Um, However, for teams trying to get down to the meat of it, trying to actually just get started with putting continuous improvement culture into their team, what are some recommended ways to actually get started with it? Because it seems like people are staring at dashboards, people are trying to figure out different behaviors to optimize. What's your top what's your top recommendation for a team looking to start? Where should they begin?
Yeah, absolutely. First of all, they need to understand the significance of the CPU limits. There are lots of articles talking about that. Why do you need to set them up? What is the best way to do that? And today's webinar was trying to provide some sort of a summary or the best practices to do this. This is very important. So number one, your team is basically is your partner in doing that. You cannot really manage all of these yourself if you're a DevOps engineer or an infrastructure engineer. That's number one. The second, you need, as I mentioned, to prioritize what you want to achieve. Are you after saving money? Are you after stabilizing your system, or having just the best practices? Even if you do not have these two problems in terms of stability or saving money, you want to make sure that your team is applying the best practices. Again, it's pretty much like, for example, you can ignore setting the root, the root privilege flag inside your container or your pod. You can argue and say, most of my pods and containers are internal. Really, I don't need to do that. But if you're using open source, there is a possibility that malicious code will find its way inside your container. Your container is going to get root access to your VM and eventually leak some of your data outside, or even do worse than that. Same thing for CPU limits. You can ignore them. They may not cause you problems immediately, but you wanna implement the best practices. You wanna protect your system from some bad behaving pods due to a bug or due to something unexpected. And also, you want to protect your microservices and give them the minimum resources to run properly or get started properly. So this is also going to impact your system. So that's also another aspect of it. You want to also, the third thing is you want to have the right cadence. What is the right cadence? The question that you want to have in mind: what is the right cadence for me to manage those resources? Do I need to do this every week, 2 weeks, or a month? You have to have a regular cadence. And what impacts that cadence is basically how fast you update your software, the variability of your workloads, the you know the resources that you have, the size of your team to manage those, and of course the business goals. Everything at the end of the day need to be connected to your business goals. Are you saving money, or there's something more important for you in that case to manage the limits and requests? So these are the three or the top three kind of recommendations for anyone to have the right mindset for his team or her team to move forward with the request and limits or capacity management in general. And if you notice from that series, it's not just a small thing you set and forget. It's a mindset, it's a culture that you need to have inside your team. Cool. Hopefully that answered the question.
Yep. Thank you. So we'll wrap here, and we will be sharing the replay via our website, on our YouTube channel as well. So Stay tuned. And as we said, we will have a part 4 coming up in a couple weeks. And we also have a CNCF webinar coming up on November 4th of this year. So stay tuned. That's in about 3 weeks, where we'll be going in depth on Kubernetes governance. So thanks a lot, Mohammed.
Thank you very much, Jad, for hosting me. Thank you, everyone.
All right, bye-bye.